So today we're starting with 7.2. We're beginning our graphing. And I've got some certain rules that I need you to follow every time you do a graph. Because if you're not following these rules, you're going to get points off A, off the quiz, or B, you won't get credit for your homework. So the first thing I want to say is when I have a, let's start with this one right here, since I have to kind of get started right away. When you're drawing your coordinate plane and your line, I expect that you are using a straight edge for all parts, right? That means you can use your student ID as a perfect size for your graph notebook. You can get a small ruler. They have these little 6-inch rulers, but your student ID works great. I used to be at the skate park. I would, be grading papers. I'd pull out a credit card and I'd make my key while I'd be grading tests. I want you using a straight edge. Does everybody understand what that means? I have this nice little Amazon gift card that I think Lily gave me, and I bought some books. And after I bought the books, I wrote used on it. And now that works perfect for making my graphs. The next thing, on your axes, I need you always to label your, oh, whoops, that's ugly. I was in line mode. I need you to label your x-axis and your y-axis, every graph. Got it? I'm going to jump down to, as I'm covering these, all lines have arrows. So I should see arrows on every line, because when we're graphing these equations, they go on and on forever. Got it? So I should see arrows. That would be minus a point for the arrows, minus a point for the x and y axis, if you don't show it on a quiz. Now, when you're writing, I'm going to just kind of cover this up for a minute. Okay, when you make a graph, I don't want you to make the graph like you see it now. All right, so notice on this one, my line is kind of in the middle of the boxes. I never want to see you do your line in the middle of the box. Don't do that. The line, when you are creating an axis, it goes right on the graph line. Do you understand? And you don't need to number those lines. Is that clear? You don't need to number this. Because we count them. So if I need to find 2, 1, I'm going to count 1, 2 across and 1 up. Just writing those numbers is really going to cloud it up. So if it is assumed that each one of those is a unit of 1. Unless you need to do units of 2, let's say you want to change the scale. So if you want to do units of 2 and every unit is going to equal 2, you could go 2 here and 2 here. And that shows me on the x-axis every line is equal 2. I don't have to do every single one. Do you understand? Okay. So we left off at, I'm going to erase it. So I did labeling the x-axis. We've talked about always using a straight edge. We've talked about always, the axis is always written on a line of the graph paper, both axes. No baby lines. So here's a baby line. Here's your graph, right? This is a baby line. Not the graph, but this is your baby line. Do you understand? No baby lines? The line for the graph should be, it should be the size of the graph. Got it? That's what I mean by no baby lines. Is that clear? Yeah.
What does it mean the axis always written on the line?
Okay, one more time. I'm going to go back. I'm going to add, here, I can add, never mind, I can do it this way. When we're doing this, let's go to big graph paper. Okay, I want the x-axis should always be on a grid line. Do you see that, Cameron?
Oh,
Okay, I don't want to see it like in the middle of the boxes.
Got it.
Because we use those boxes to count. Okay? I don't want to see this because I don't know. That's like to get over here, that's a half a unit. Oh, okay. To get here, that's half a unit. Okay, so don't do that. You're not doing it like this. You're writing your axes should all be on the grid line of the graph paper. And the reason why I say no, that you have to use graph paper, because doing it on notebook line paper will take you forever with your graphs. And they'll be inaccurate. Does everybody understand no baby lines? Okay, no baby lines. All right, so next thing we're doing is check, 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 check. And this kind of goes all lines. Okay, I'll go back to that. When you're doing your work, right, all lines should have a graph, have arrows. If your x-axis and y-axis don't have arrows, it's minus a point. Got it? The other thing is number 5 and 7 kind of go together. I don't want to see, I put 3 lines, number 1, number 2, and number 3 are on the same graph. Do you understand?
Yes.
What I do want to see is that, let's say you had a table. This is what I mean by table, work, and graph stay together. And let's say the equation is like y equals 2x. Okay, and so here's x, here's y. So it's 0, it's 0. It's 1, it's 2. It's 2, it's 4. Okay? I want to see everything right near the graph. Is everybody clear on that? Yes or no?
Yes.
The table, the work, the graph should all be together. Let's say the equation is x minus y equals 3. And you have to go add y, x equals y plus 3, subtract 3, subtract 3. Y equals x minus 3. And then you start doing it. That should be right next to the graph and the table. Whatever you're doing should all be, if it's related to that. Because I have some kids that will do all the graphs on one page, all the tables on another page. Do you understand? And this tells a story. Equation to table to graph. Am I clear? Yes, no, maybe. Yes.
Wait, do we also have to do the table?
Well, it depends on how I'm showing you how to graph. There's multiple ways to graph. And so one day you will be doing table method, yes.
Wait, in this right now?
Right now, we're not there yet, so let me get there. Yes, it's the first method we hit. Don't number the axis if they increase by 1. Yes, David. Okay, number 3. Everybody's having a hard time with this. Number 3? Yeah. Number 3, so when I have graph paper, right? I want your axis to be your x-axis. Don't do this and put it in the middle of the boxes. Okay, I want it to be on the line. And this should be on the line, sorry, with a straight edge. Okay, 2, always use a straight edge. This is a straight edge. Use it when you're drawing your lines. Okay, oh, I did skip one thing. So, when I have a graph, right, and you'll see this happens more so with my iPad. When you have a graph, and let's say you're, okay, and you are graphing a line. Okay. I need you to label 2 points. See how that red line is kind of like, it's so fat, it's moving off the point? If you label it, then I know where you meant to be, because sometimes your pencil's so wide that it takes you off the line. And sometimes, like, it kind of slips out. If you have 2 points labeled, 4, 1, then I will know, does that make sense? Where it's supposed to go. Yes, Adam. It's Matthew, sorry. Yeah, you can use your student ID, you can use this, I've got rulers, but I'd like you to try and bring your own straight edge. Yes?
So last year in the sketch tour we had to do 2 graphs per page. Is that the same thing now?
You can probably fit 3 or 4. Okay? We're not doing 8. Okay, let's continue on. It will become, what I want this to do is become habitual. It will take you a long time in the beginning, and then by the end you'll be going very quickly. So by the time you're in Algebra 2 and you're doing tons of these, it shouldn't take you time because this is habitual. Okay? So today we're learning to graph linear equations using X and Y charts. You don't have to write all of this. Just listen for a minute. So with one variable equations, we've been doing one variable equations. That was chapter 3. 2x minus 3 equals 11. Okay? When I solve that, I end up getting one solution. One variable, one solution, right? Unless we have those exceptions. We have a couple of exceptions. When we're solving something with x squared, there's 2 possible answers that will work here. 4 squared is 16 and negative 4 squared is 16. So I have 2 solutions. When you have 2 variables, when x is 1, what is y? When x is 1, what is y? 4. When x is 2, what is y?
3.
When x is 4, y is 1, right? What about when x is 5? 5 plus 0 is 5. What about when x is 7? What about when x is 8? What about when x is 20?
Negative 15.
Okay, what about when x is a half?
Plus 4 half.
Right? So how many solutions do we have?
An infinite number.
Infinite. So this is actually, they're going to give you an equation tonight. This is for tonight's homework. And they're going to say, give me 3 solutions. So when you have this 1, 4, this really represents an ordered pair. So x is in the first place of the ordered pair, right? It's always x, comma, y. And 4 stands for the y in the second position. The next one is 2, 3, 4, 1, 5, 0, 7, negative 2. I could also put this into a table. I have 1, 4, 2, 3, 4, 1, 5, 0. Do you understand? What tonight's homework is going to ask is that you find 3 solutions. Now, what this really is, these ordered pairs, when you go and graph the equation, right? When you graph on the equation, are you with me? When you end up graphing on the equation, what these are is 1, 4. They're points. Every point on this line is a solution. So when I say give me 3 solutions, do you have to give me infinite amount? 3. So, for instance, in homework tonight, yes, question.
I was just gonna ask, the one variable equation, do you have to
No, we haven't been graphing one variable equations. We're not graphing. Oh, are you talking? Oh, on that? But that's not what we're doing in this section. We're really, the one variable.
Like, why would you graph it if you already found it?
Huh?
Why would you graph it if you like already found it?
Well, if they want a pictorial version of it, that in that case, if it's at, what was the answer?
7.
X equals 7, so 1, 3, 5, 7. That would look like this, because it's just a linear equation on a line. We don't need to put it on a coordinate plane. There's not 2 dimensions. Do you understand?
Yeah.
Now, we will do x equals 5 on a coordinate plane, and that's a little bit different. But let's, for right now, just stick with what we're doing. So if the equation, like number, let me start with 7-2. So if it says find 3 solutions, and the equation is y equals 3x. Oops. Y equals 3, no, sorry. Let's make it harder. It'll be like y minus 3x, this is the example in the book, equals -2. It's usually easiest if you get your y alone first. So what would I need to do?
Plus 3x.
Add 3x, add 3x, get the y alone. Y equals 3x minus 2. Now, if I'm doing 2 solutions, I get to choose. Make yourself a little table, okay? And I'm going to choose my x's. Okay? I usually go with a negative, a positive, a 0, whatever. It doesn't matter. I'm going to go with easy numbers. Y equals 3 times 0 minus 2. What is that? Y equals -2. I'm going to do it again. Y equals 3 times 1 minus 2. Y equals 3 minus 2. Y equals 1. So when x is what? What is the y? 1. And when, I can do it again. Y equals 3 times 2 minus 2. It's 6 minus 2, which is 4. So what's the ordered pair? Huh? 2, 4. So there's your 3 solutions. I don't care if you put it as a table or if you do 0, -2, 1, 1, 2, 4. Do you understand? You can do it like this or you can do it like this. Do you understand the homework for tonight? All right. I'm thinking I might, let me just start by, let's start some graphing. That was part of the homework. So the other part of the homework is going to be this, where they're going to say, determine if the ordered pair is a solution to the equation. So we substitute it in. You don't really need that question mark. And then we get 11 is equal to -5. Is that a true statement?
No.
So we show it's not true, and we say no. 8-3 is not a solution. It's not on that line. It's not a point on the line. I'm going to substitute again. Actually, why don't you guys do 2, 3, and 4? Go. Pause the recording and do 2, 3, and 4. What am I starting with? What do I substitute? 12 equals 8. Good. Oh, -4. Good. And so is it a solution? Is this a solution to this equation? You're going to say yes. Okay, number 3, who wants to substitute for me? Somebody else? Let's go with Aton.
So I substituted to make it 6 equals 13 plus -7.
which is technically
6 equals,
6.
and so is it a solution?
Yes.
Yes. Next one, Ashley.
So 1 substitutes y minus 3 equals 5 plus 1. Oh, wait, sorry, plus 1 equals to negative 2 equals to 6 which is 0.
And I want to see that slash through it, and you're going to say no. So that's what you're doing for the homework tonight. Okay? I'm going to start. Let's start the graphing right now. I might repeat it tomorrow, but let's just start it and see how far we can get. All right. So again, we're just trying these points in the equation. If it works, it's a solution, right? 3 times 2 is 6, minus 1 is 5. Is that a true statement?
Yes.
So it's a solution. 3 times 4 minus 5. 3 times 4 minus 5, that's 12 minus 5 does not work. Be careful with your negatives. You're going to have to do some fraction. Okay, so let's start with our rules of graphing. If you want to maybe get started with some of them, if they're basic ones. I usually tell my kids when they're starting to graph, I would like you to make 3 columns. So you're going to do something like this. Oh, God. Really having a hard time getting that together. Okay? And then I'm going to go. And then I'm going to put my y here, and I actually put the equation 2x minus 3 equals y. So I can see your work. Now remember, with these x's, how do I figure them out? Yes. I choose. You get to choose the x's. You want to choose a negative, a positive, and 0. You want to keep it small. You don't want to be putting like in negative 100 because it's going to be off the graph. So I'm going to try a negative, a positive, and 0. So let's start with negative 1, right? So 2 times negative 1 minus 3. 2 times negative 1 is what?
Negative 2.
Negative 2 minus 3, what does that simplify to?
Negative 5.
All right, so there it is, and that's my ordered pair. The ordered pair is negative 1, negative 5. Okay, so I'm starting at my origin, and then I'm going to go across 1 and then down 5. Right? Negative 1, down 1, 2, 3, 4, 5. I'm going to try 0. That's an easy one. 2 times 0 minus 3. It's 0 minus 3 is negative 3. What's my ordered pair?
0, negative 3.
Okay. I'm going to try positive 1. 2 times 1 minus 3. It's 2 minus 3 is negative 1. So that's 1, negative 1. So I'm doing 0 across, down 1, 2, 3. And I'm doing 1 over and 1 down. And then I'm going to draw my line with my straight edge. Now see how, oh, you can't see. I'm going to just draw this right now and then I'm going to redo it. Do you see how my line slipped and didn't hit the dot? It didn't hit the point. Do you guys see that? That's why you're labeling that. To tell me that's what I meant it to go through. My ruler slipped out, so you're going to label negative, positive 1, comma, negative 1. You don't really have to write the positives. Just pick any 2 points. And I would like 3 points per line. So that would be, that is 0, negative 3.
For us to label it like on the graph, or like
Just like I did it. Do you understand? But do you understand why we're doing labeling 2 points? Has that happened to you while you're drawing it and your ruler slips out? Graphing is exact. So if you have like a fat pencil, it might not hit the intersections. The further away you get from that point, it just might slip out. So that's why we're labeling. All right, so do you understand how I'm doing this graph with the work in it? What did I do wrong from my list? Did I label my axes?
Oh.
Yes.
You forgot to put the arrows on the line.
Oh yeah, Yamasaki will take points off for that. -1, -1.
So you guys label the bottom dot?
I only need 2 points labeled. Any 2 points create a line, so I don't need more than that. Does that make sense? Sure. I mean, you want to kind of just make sure that it's clear that you can read everything. That's why I don't have you labeling the numbers. Now, questions so far? I know you probably learned a different way to graph, but this is one method and it's a way that I need you to do when you're doing these problems. Okay, when you're doing tomorrow night's homework, you're going to be labeling the, I want you to do the work in table format, as opposed to using y equals mx plus b. Do you guys remember that from last year? Okay, well, I want you to make a table. It's a pain in the butt, but it serves its purpose, especially for second semester. We got to know how to do table method. Okay, any questions here? Let's see what my work looks like compared to. You could do it like that too. That's fine, as long as you have a place to show your work, you know? Do you need to do this many? No. So this line is this equation. And we put the arrows because there's infinite solutions. This line's going to go on forever and ever. Yes, David?
Are we going to have to do the graph with the homework or no?
Tonight, I've split it up so you're doing half the homework tonight and the graphing tomorrow night. Okay? All right. Let's pause there.